Hello and welcome to yet another video. Today we have an MSI X570 Gaming Plus on our board. So I love X570. I love to fix this platform. I've had quite some of these before. And this particular one is supposed to be stuck on a CPU LED. So it seems to be turning on as of what information I've got from the previous owner, but it never moves on from the CPU LED. We have these LEDs right there, the debug LEDs. So let's start with some with our usual measurements. So let's get a ground and let's see, 12 volts, kinda low, but might be fine. 5 volts, that looks fine. 3.3 volts, also a little bit lower with under 1 kilo ohm, but should be fine. Then 5 VSB, also not too high. PS on, high. Okay, some of these really didn't look too high, but we're going to continue with this. The 12 volt CPU looks fine. Let's put a CPU into here and let's check once more. So putting a CPU into here and checking then. And still kilo ohms and rising, so that is fine. Now let's just, that's the 1600X. So let's check the BIOS battery together. BIOS battery says 3.1. This seems to be that this has been replaced before, but because that is quite high. Let's see for around the SIO if we have any problems there. And checking random capacitors around the SIO, and looks like we have high resistances all around. That looks very good. Okay, and I think we will go over to see for the passive power consumption from this board to get more information out of it, because what we've seen so far, everything wasn't too special. Like some of the resistances on the ATX connector looked lower than expected, but I won't interpret too much into that for now. And let's see what our passive power consumption is. 150 milliamps, nothing. So that looks very healthy, very just normal. Let's connect a power button onto here. Let's get a speaker onto here, and also connect our debug cards. Okay, and let's push the power button and see what happens. And we're stuck on 55, which means DRAM missing. Okay, so this is already not a CPU LED. Very interesting. Let's get RAM into here. So let's see now. We have RAM in here. We have a CPU cooler also attached. We're stuck on postcode A. Oh no, it's AF. Let me connect a screen onto here, because the power consumption looks very good, around 3 amps. The image that you see right now is a frozen image that is from a previous board that I've repaired. This is not from this one. So we do not have any activity on the keyboard as of yet. And the power consumption seems to be... Oh, now we're stuck on a CPU LED as far as it seems. Interesting. Let's get that boot screen out of here. We are on the very first LED, which is a CPU LED right now. Let's reset the board and see how that behaves. Okay, that didn't seem to have any effect on it. Let's turn this off. Okay, it's properly off. Let's turn this on again. So we have CPU LED. Current was jumping from 3 amps down to 2.7. And now we're actually stuck on a CPU LED. That's very interesting. Let's quickly drain all of the power out of here. So I've disconnected that power. And let's also get the BIOS battery out of here. And let's also reset the BIOS by shorting these two jumpers on here. And let's now see again if anything is different. So CPU LED, 3 amps, power consumption 2.7. And still stuck on 2.7. Interesting. Let's try this again with taking out the RAM that I've put in, because that seemed to have changed something. And then we get to a DRAM LED actually. Interesting. That is very weird behavior. Okay, let's try different RAM slots. So now in a different slot, let's see. And we keep on staying on the CPU LED after having supplied RAM into there. Let's swap even further around, because this is an interesting jumping case of where we get to DRAM LED as soon as we don't have RAM in here, but as soon as we have RAM in here, we go to a CPU LED. And still CPU LED. We have one more spot that we can check with the RAM. And same behavior in the last slot. Very, very interesting. So I would think this might be a BIOS problem actually, because this seems to be something weird with CPU recognition and with RAM recognition. Let's for now try a different CPU in here. This was the 2200G. Let's swap to a newer generation 3000G and see if that brings any change to the table. Let's turn it on. And we have also CPU LED. The amps is a little bit different than we had before. But we also stuck on a CPU LED. It doesn't move on from there. Okay, even trying to restart it, it's still going to be stuck on a CPU LED. Let's try with this CPU now to switch up on the positions. And in a different slot, we still are stuck on the CPU LED. One more thing I want to try is to connect a normal CPU into here, not an APU, and see if that has any change to it. And with the 2600 in here, we get the same post behavior as well. Stuck on a CPU LED, not going to RAM. So one of the first things I would want to try is to flash the BIOS. And the interesting thing here is that this board has an onboard utility, as you can see by the button there, to flash the BIOS. So you probably will need to connect a USB stick to this port right here and hit the flash button, and then there's going to be an LED lighting up. And I will be getting the BIOS now onto a USB stick, and I will show you how that will look as soon as I have that ready. So we now have the USB stick inserted into the right slot, and when turning this on, you don't need the CPU, you only need the 12 volts power connector here and the 24 pin. You don't even need RAM in here. And what you do is you press the button. It should be only once. And one thing I would always recommend, get a USB stick that has an indication LED like this one, that you can see that something is happening. And there's now the flashing, the blinking LED right there, and the board has started by itself. As you can see, we have power consumption, and also we have a CPU LED right there, and the fan has started, that is on the chipset. And what we now will do, I will now have to wait until this LED isn't blinking by itself anymore. And as soon as that is done, it might shut down automatically, it might not, but it would tell me that the BIOS has been successfully flashed. And then we will see and try again with a processor in it and see if that has helped. And now the board is finished. As you can see, there's no indication anymore on the USB stick and no indication more on the board, but the board is still on, still drawing amps. And so what we do is we going to manually shut it off now. And having done that now, let's now populate it actually. Getting a CPU into here. Let's go with an APU again. And let's see if that has already solved our problem or not. And let's see now. Let's get a CPU heatsink onto here. And we're still stuck on a CPU LED. And it seems like nothing has changed. Still CPU LED stuck on that. And probably still the same behavior if we disconnect all of the RAM. Let's do that. If we disconnect the RAM and now try this. Now we move on to a DRAM LED. Very interesting. Very weird behavior. One thing I want to try now, I want to see for data lines on the DDR if anything is wrong with that. So I was not able to find any problem regarding that. I want to now go in around the socket area of the main board with the microscope and see if there's any broken components or anything like that. And if we haven't found anything of that, I would want to go around the DDR as well. And if I see anything, I will get you back onto here. So I was able to find something in an area where I did not expect it. This is close to the SIO on the edge of the board. And in the first second I thought I saw some thermal paste. But what I actually was able to determine is that this resistor got broken in half. I do not know what this is responsible for, but it doesn't look too important to be perfectly honest. But I'm not too sure. So we will need a board view for this board and see what the nominal of this resistor is and go from there. So for MSI boards, you always want this number, which is MS7C37, and this is the revision 2.2. That is very important to know for getting the board view, because this is how the board views are called for MSI boards. And right now we have the board view open for this, and the area that we have is this above the SIO, and it was this resistor here. This is a 10k ohm resistor, and it is responsible for 3VA feedback and SIO 3VA. So this is for the feedback voltage for the SIO. So I think this will be our culprit. If this is actually faulty, which it really looks like, then I'm pretty sure that this will get our board fixed. So let's remove that resistor and replace it with a good 10k one. So now let's get just some flux onto the area. And we will be removing it just with our soldering iron, because I think only one side of it will be connected. Let's see, okay. It still holds on to here very firmly. Trying to heat up both sides, and there it is. So the resistor is now removed, and let's get a new 10 kilo ohm 0402 resistor onto here. And here's our resistor. Let's get you onto there. So what I like to do is to tack on one side of the resistor like this, and then get the hot air station to make sure that it is properly soldered on both of these sides. And it now moved nicely into place. And while the board is still hot, let's clean the area up. It will make it a lot easier to clean off the flux when it's hot, because as it dries it gets hard and it will be a lot harder to get off of here. And now I'm very interested in how this board behaves. So let's see. We push the power button now. And there it is booting. That is very good to see. We have CPU, LED, we have DRAM. Let's connect some an output onto here. Let's get the post screen in. The post screen that you see right now is still the stock one from before. But we should be getting the MSI boot every second. Okay, it turned off by itself. It keeps rebooting. Well, we have reset the BIOS and there is the BIOS screen. Very, very nice. Very, very nice. Just a little 10k ohm resistor in a place where you wouldn't have expected it was causing this board to not boot, and have this weird issue with the RAM LED and the CPU LED. Very, very weird. Well, let's get this board built up with RAM, with a PCIe device, so the graphics card with M.2, with some USB devices, and let's stress test this thing. So now let's boot this board up and get into Windows and see if everything is working like it should be. So there's our boot screen right now. And let's see if we can go instantly into Windows. I have an M.2 installed into here. And now we're loading right into Windows. And now we have our Windows screen. So we are on desktop. And as we can see, we also have Ethernet already connected. So that is also working. Let me get a stress test into here. We're going to be stress testing the CPU. Going to be running linpack to test the system. And I will get you back as soon as this has passed. And with that, we have 2 passes of linpack without any problems. And let's do a 3D application. So we're going to be running Heaven's Benchmark also. And with that, also our 3D application has been successfully finished. And then there's nothing else left to test on this board, because let me show you. We currently have 4 sticks of RAM, we have Ethernet, we use USB, we have the PCIe device. So everything that this board had was a 10 kilo ohms resistor that got knocked off close to the SIO area, just to the very edge of the board. I can't really tell you how that happened. The only thing I can imagine that someone had something in this PCIe slot and with that damaged this component right here, because there's no screw holes, and I don't think while putting the mainboard into a case someone would have destroyed that. So yeah, I think that's how this board got damaged and got into the state that we got it from. And the boot behavior was very weird though, like the one that we had, that we have a CPU LED as soon as we have RAM in there, but when we don't have RAM in there, we get to DRAM LED. This, like, it's very confusing how that was a symptom of the SIO not working properly, because the voltage for the SIO wasn't there. Maybe, I do know that the SIO has a lot to do with like monitoring some voltages or enabling some of the voltages on the board. But still, I wouldn't have expected that to be the problem out of the symptoms that we had with this board. But I'm very happy that we got it fixed this quickly, because I wasn't looking around very long on this board until I found that. Because, as I said often enough, physical damage very often happens in similar areas, like around screw holes, around mounting holes, around mounting for the PCIe, sometimes on the back side of the board. So you've seen me diagnose that many times before, and this time again, a beautiful X570 from MSI has been saved by replacing that 10 kilo ohms resistor. So I hope you learned something and enjoyed the video. Thank you very much for watching. Hit the like button, hit the subscribe button, and this was Mainboard Medic. Thank you very much, and goodbye.